Give me a yell, sweet as. Okay, so let's try this. Right, we're into it. Okay, today, tabular versus multidimensional. Let me just start by saying we're talking about analysis services here. We're not talking about the column stuff that's in SQL Server. I'm just looking at what's going on in the presentation layer. Okay, a little bit about me. I'm Nick Draper. I'm a BI consultant for Intergen. We're the yellow guys downstairs. I've been doing BI for a while. I like it. I hope you guys do too. Okay, a bit of an agenda, a bit of a look at where we've come from and kind of where this stuff is going. I'll try and talk about X velocity and what the BISM, the BI semantic layer is. Then I'm going to explain the architecture behind that, the tabular architecture, and why that makes sense and why Microsoft are going down that path. So there's a lot of discussion about there saying, well, we had the best, OLAP server in the world. Why the hell are we throwing that away? Because it seems that way. But there's some good reasons, and I think we'll get to comparing the two, and I think you'll understand why. Okay, so yeah, we'll look into design and comparison. This is not going to be a code-heavy session, so if you're a real code monkey, you may fall asleep. Okay, so back in 2005, we got the UDM. So Analysis Server had been around for a couple of versions, and they brought in 2005 the UDM. They allowed you to do a whole lot of multi-dimensional linking between facts. It's pretty cool. That really exploded the market for Microsoft, and the technology hasn't moved massively along from 2005, 2008, and R2. Simple, only one modeling tool, reasonably easy to create things, but if you want to write MDX, that's a little bit harder because it's quite different to the relational stuff. And now we have the BISM, the BI semantic model. It's a great term, I really like it. A little bit difficult to explain to my wife what it means, but I'll give it a go. So it's a model where we separate the BI layer from the tools that are connecting to it. Okay, we have one modeling tool, but we now have two types of model within analysis services. They're all called part of the BISM, which is kind of a theoretical term. We have the tabular one and the multi-dimensional model that we had in the past. So it's kind of crucial at the beginning that you understand architecturally which one you're going to use. Because right now you have to choose one at the beginning of your project and you can't interchange between the two. Okay, so this is the picture that sells us 1,000 words. And I have some prizes, by the way. I'll give away a USB thing. If someone can tell me what's wrong with the picture, put your hand up. Has anyone got an idea that what's not quite right with that picture? Sorry? Not really. No, I guess so. Reporting services is kind of power view. That wasn't what I was looking for, but I'll give you a stick anyway. I've got one more stick if someone else can get the really easy bit. No, it's even easier than that. Oh, okay. We've renamed it, I'm going to go. We had this Vertipack engine they created and they brought it through and everyone kind of said, oh, that's a nice name. But what they've done with 2012 is they've rebranded it, they've called it X velocity. And it's all about this technology where they make things run a lot faster. Okay? And the technology is available both in the SQL engine itself and in analysis services. So I'm just talking about the analysis services end. If you can get up for the 9 o'clock session tomorrow morning, I'd encourage you to come along and learn about the column store indexes in SQL Server, because it's another piece of the puzzle. It's using the same sort of technology, but it has a different use case. Okay, so it's important to understand where they fit and when you should use which one. Okay, so to me, one of the big things I want you to take away is this concept from individual to enterprise, right? And I've been throwing this slide around for 6 months now, so it's getting old, but I like it. So the concept is that you now have this ability to create things in Excel, and you can handle, tens of millions of rows on a spreadsheet, on your desktop, and that allows new users to be able to create BI solutions. And we're talking business users, business analysts with different skill sets. They're great at Excel. They kind of understand the data because they tend to be working with those business systems all the time. But they may not have grown up with IT, so they probably don't understand change control. They tend to hack things. Now that, I think, is a great tool, and it's awesome for those, those Fridays when the CEO comes and says, I need you to get me the answer to this by tomorrow. And I don't mind if you work all weekend, but tomorrow means Monday at 9 a.m. If you're trying to answer those problems, you can't easily work with a massive data warehousing tool. So Excel allows people to chop things up quickly on their desktop. So that was all good, but we used to say, look, that came out in 2010. It was cool, but it was really only good for prototyping. There's a whole lot of things it doesn't do. It doesn't do change control. It creates big files, so they're not easy to transmit around. It doesn't deal with data quality or anything. But so you can then bring it into SharePoint 2010, and that allows you to scale up to what they say, hundreds of millions of rows, assuming you have more than a tiny box for SharePoint. But that gives you the ability to then pass these files around and allow other people to use those BI solutions. And it gives you some security, so you can secure it that if you can access that page, then you can see the content. It gives you some sort of change control because you can say this person can control and update and pull the model down and adjust it. But it's not a full enterprise controlled system. Okay? But what we've got now with 2012 is we've brought that into analysis services. And that's huge. Now, apparently, you can do billions of rows on SQL Server, right, with great performance. But it also brings in the ability to have proper change control. You can do row-level security with roles, all of that good IT governance things. And the other piece to this is it allows a transition without having to rewrite everything. You can have your business analyst knock something up, they can put it into SharePoint, you can start to use it, and then when you say, I want to incorporate this in my data warehouse, I want to put some rigor around it, I want to make sure that they did the joins properly, you can then hand that over to the experts in IT. Okay, so what I wanted to do briefly is show you this, because I'm always been going, what the hell, billions of rows? That doesn't make sense. There's no way. So I'm just going to clear the cache, because I was playing before. The first thing I want to show you is on my little laptop here. Here's my little table, and I've got a billion rows. And it takes, 1 second to count them. I think that was pretty cool. But that's clearly it can handle it faster than I could. I actually built this table based on a SQL database I've got on here, which if I run that query to count the number of rows in it, it takes 5 minutes, which I could do because that would save me talking, but let's not do that. So that kind of answers my question about can it handle it, can it scale? I've got a laptop here with 15 gig, it's not bad, but I'm handling a billion rows there, and that tells me it's good enough for New Zealand. Okay. So, what is this X velocity and memory thing? Okay, so the story is it's an in-memory database. So instead of having it stored on the data on the server, it holds everything in memory. So it's available, it's fast. The other big thing is it's based on relational constraints. So one of the big things about the multi-dimensional databases is because it's using MDX, you need to understand the relationships between all of the dimensions. And that's quite hard to get your head around. If you're trying to write a query, you must understand that this dimension and this hierarchy is related to that. And if you miss it, it will just send back the wrong data. So X velocity with the simple relational modeling idea is just simpler for people to understand from a SQL background. Column stored database. It's I'll come into that in a minute. And compressed. These are the key things to understand about why it's different. So let me explain why. Traditional data storage. This is how we've been doing it for 40 years, I guess. I'm not that old. What we do is take a row and we stick each row in. Right? This is the OLTP thing. That's really good for transactional systems where I've got a row, I've got a sale, I'm putting it in. I want to do it that way. It's fast to write, it's fast to read for a row. Okay? A column table storage, it kind of goes around the other way. So instead of sticking a row in, we stick a whole column in, column by column. Okay? And now this means it's easier for me to access a column but not a whole row. And that makes sense for BI queries. But when you're doing BI queries, you're not often looking for the complete row. You're normally saying, tell me what the sum or the average of for these million rows. Okay? So you want to access a subset of the columns and add them up or aggregate them or apply some logic to it. So that's why column table storage is becoming more common. All of the vendors are bringing these sort of column store databases out for analytical applications. Okay, so the next piece to understand is how X velocity storage works. Okay, so the way it works is that you have a table, and on my little picture here, so this table's got 3 columns in it. We put the data in, and what it does is it sticks the tables into what they call a dictionary and segments. So the segments are the sets of data. So I have a dictionary that explains what the data is, and then I load 8 million rows per segment. And so what it does is it sticks those on a page-by-page basis. When I was looking in the old model, I would stick a row, and then another row, and another row. So my page has a bunch of rows. When I'm going a column way, it loads 8 million segments into a page, and then, so the fragmentation and the trying to access things across pages works better. Okay? So we have a dictionary to describe things, and then the data, and then the more data. Okay? So the next thing that's important to understand is calculated columns. These are not intrinsically tied to the same storage. They are add-ons. Okay? They're treated the same as another column. But because they're not tied to the column, it means that you can create them afterwards. You can drop them. It doesn't matter. It's not going to affect the core storage. So it means it's more flexible and detached for you to develop additional metrics and calculations. Okay. Then we have hierarchies. These are treated the same way. So the hierarchies are, ways I want to group and sort my dimensions, like if you think the year, date type thing. They are also treated as a separate object from the data. So on each column I'll have the data, I'll have a dictionary, I can have calculated columns, and then I'll have a hierarchy. Allowing these things to be separate means that I don't have to reload or rewrite or adjust my billion rows because I want to add a hierarchy or a calculated columns. That makes it a lot faster from a performance perspective. And then the other piece is the concept where we have relationships to another table. So the relationships are stored as a separate object, allowing links and tying bitmaps to the columns and the rows on the table that it links to. So that means it can immediately go to the relationship object and find the corresponding attribute in table 2. That's a lot faster than having to create the join and translate between the two. Does anyone, yeah, no questions, cool. I thought that was really complicated. Okay, so the other thing that makes this work really, really well is the idea of dictionary encoding. So at the top of our column, excuse me, we have a dictionary. Okay, and that's allowing us to summarize things. So if you look at this, what we've got on the left at the top is a bunch of IDs and colors and stuff. And so the dictionary takes that and summarizes it. Okay, but that becomes your key to the data segments. Okay. So when you're loading your data, a lot of the work that the engine is going through is creating these dictionaries to work out the distinct values and how it can summarize data and hold it more effectively in a compressed form in memory. Right? And that's really important because it needs to work in memory. If it can't compress it enough to fit on the environment that you're putting it in, it will fail. Yeah? So the other main compression technique they use is called run length encoding. So this is the concept where we have a run of items. So if you look at like the year, right, it might be a column of 8 billion rows or 1 billion like I've got. But if it's only got 3 years data, that can be summarized by having 3 different values and then understanding where the counts go. So it also understands intrinsically the order of columns, which is slightly different. You don't need the keys. It knows that this was the record that was first and the second, and it maintains that order. Okay, so you're getting these really small dictionary type tables for long columns, as long as the cardinality of the column is small. So when you're thinking about building these things, what is critical to making it work well is trying to only bring things into your model that have as limited cardinality as you want or you need to use. Because if you look at this last one, right, sales amount, years, there's only 4 records or 3 in this environment. There's only a few products, but when I come to sales amount, I can't really compress that because they're pretty damn near all unique. So when I go and try and bring this into my engine and compress it, it's not really able to do it. So if you're trying to bring IDs into your tabular model, it will take a lot of space. And that caught me the first time I was trying to build this. I brought in everything and I had 1 billion rows. I'm going, I need the primary key. And suddenly I had a massive table and it cried. Poor little computer. So there's a couple of things you can do here to fix that. One of them is only use IDs that are important for analysis. In the old system, we used to quite often keep the IDs in there because it allows us to run an action to pull those back and give people the keys to the transaction they're looking at. That's not as wise here. Okay? There's a couple of techniques that you can use to get around that. The first one is to use a report or something that drives an action that runs another query to go and pull the keys from like a pass-through query. The other way is to split the key of your ID into multiple things. If you think about your, I guess, sales order ID, you know, if it's a numeric key of 12 characters, you could split it into 10 columns. And then you've got low cardinality for each of those columns. It means if you're trying to query that, then you can put it back to, you need to put it back together. So you could put that back together as a calculated column that is run when you make the query against it. Does everyone understand that? So the idea is that what you're trying to do is make sure that you're compressing the data that you're putting there for analysis as much as you can so it's small. Because the work is compressing it, but unpacking it to put it back together is just a little bit smaller and faster. I've had a couple of cases where we've found this. We've taken what seemed like a small data set, but we put too many keys in there, and the performance is just terrible. And it's a little bit difficult to understand if you don't get the concepts of what's going on underneath. Okay, so I just wanted to show you briefly how compressed we're talking about, and the simple way to do that is to look at, this is my source database, and it's kind of 190 gig. Okay, and my tabular model, which is with my billion rows in, is only sort of 9. Okay, so it's taking 200 gig and it's compressing it down to 9 And then I can run that in memory on my machine. And I get all the performance that I need. So to me, they are the critical things for you to understand when you're using this technology. It's mainly that you need to make sure that you understand that compression is important and that you're loading the right type of data, but only what you need for analysis. Every time you throw an extra attribute in there that you don't need, you will slow it down and you'll add resources required. Okay. So, moving on to server installation. When you're putting this on, you have the ability to install it. By default, it comes in and says, I'm putting SQL 2012 in. The default's the multi-dimensional and data mining. But you can also put SharePoint or Tabular as separate installs. It's an instance level choice on the server. But I guess the key really is that you need to understand that they have different uses. And I guess my next slide is probably the best way to show that. This is the next thing that's critical to understand. Tabular has different needs. It's critical that it's got a lot of RAM because as soon as it runs out, it just won't process because it can't put that data into memory to be able to work it. Okay, the speed of that RAM is critical because it needs to unpack things every time you write a query. Number of cores is important, but the speed is a lot more important, obviously, okay? And then disk speed, it really doesn't matter. So they're totally different use cases. The reason disk speed doesn't matter is the only time it uses the disks is when you turn it on. Right, the first time you turn the server on, it says, where's that? I'm going to load it up. And then it's there, okay? So if you're looking at the old multi-dimensional system, you would be saying, oh, it's really good to get solid state disks, and I'm going to spend a whole lot of money on that. And you'd have some RAM, but not a huge amount. So my suggestion is you don't put them on the same box because they just won't cohabit well. It's fine for demos when you're selling people things, but it's not a production thing. Okay, distinct counts. Now I want to talk a little bit about what the tabular stuff is good at that multidimensional isn't so good at. Okay, so in the multi-dimensional world, distinct counts are really difficult because it doesn't know how you're slicing the data. So it can't pre-aggregate those without a lot of work. So when you're trying to count distinctly the number of customers who have sales, what it does, it's easy to create them in the old system, but it has to build those calculations at runtime. Okay, so they can be slow. It's okay if you've got one, but what will happen is clients tend to want lots and lots of them, obviously, right? Because they're really good. Okay, in Tabular, it's much easier. It's in memory, it already knows it. Because of the way the tables are structured, a distinct count is easy. It's just using those dictionaries and those run line things. It just has to unpack it. It's got relationships, it can jump to other tables, not a problem. But you need to use the DAX formula, so they can get long. Okay? And the other point, the fact that you don't need to reprocess it, if you're trying to do a distinct count in analysis services for the old multi-dimensional model, every time you create one, it's a new process. You need to reprocess the whole queue. Okay? With this, because it's all decoupled, you can just write it and it's there. Okay, now I actually have some code. So we've got 1 billion rows, and here's a little distinct count. Oh, looking at the so this is looking at the internet sales and grouping by day, the number of rows and the number of customers and their IDs. Okay, and that took 7 seconds. if you're trying to do that against a billion rows on a laptop in the other system, we'd be here till tomorrow. You're missing the drinks tonight. Okay? But, you know what I didn't do? I didn't clear the cache, so maybe that was cheating. So, it has a concept of a cache, so it will store stuff. So let me try that again. So this is running it uncached. Oh, 6 seconds. Maybe it wasn't cached. That's pretty cool, right? I was going to do this for 4 billion rows, but it seemed irrelevant because I don't know anyone who has 1 billion rows. I'm curious if anyone's got 1 billion rows in their databases. Look at that. Well done. I'll give you one of these when you come back later, because maybe you need more than one. So what is your database? What kind of information is it that has 1 billion rows? Right. Very cool. What kind of hardware is it running on? We could put it on my laptop. Okay, so essentially distinct rows, awesome. Okay. Oh, hang on, let me go back to that. Where's my other one? So the next concept that you need to be aware of is there's no aggregations. In the multi-dimensional world, we should be defining aggregations properly. So they're there to create effectively and store summary level data, right? So that it doesn't have to calculate it on the fly. But they're not difficult. They're not easy to get right. And you're just throwing more data in there, so it does slow things down. They need to be reviewed because it's built there, and so they need to be refreshed, and no longer care about that stuff. Except I still like the old cubes, so we'll come back to why. Okay, leaf level calculations. So in multi-dimensional, sometimes you need to get down to the bottom row and create calculations about that. So and that commonly we're talking about currency conversion, all of those things where I need to do averages or something. You don't need to change the model, right? One of the tenets of this is that you should not have to change the data model because you're doing new queries. So in the multi-dimensional world, you kind of needed to pre-plan all of the things that people were going to ask. Creating... We have a lot of clients where we'll go and we'll put some analysis services databases in there, and then they come back with a huge list of calculated measures and members that they want us to create, because they suddenly realize as they use it, we need to, do last year, this year, last year, whatever. And so that is not such a hassle in the new system. Okay, leaf level calculations, so they're faster. I just want to, and this is a little hard to see here. What we're doing is we're taking a total product cost, so we're summing things. This is just getting the high level rows that we want to summarize, right? So it takes 2 seconds to go and work out the number of rows by year and the tax and the total cost. That makes. But if we want to go and do a leaf level calculation where we're going and getting a mean average, dividing one by the other, that's really hard in multi-dimensional. You're taking one value, you're dividing it together. So you would expect this has now got to scan through that billion row table about 6 times. Oh, I think I need to clear my cache again. So it's going to take a bit of time. 4 seconds. Is that pretty cool? That's pretty cool. Some people are nodding. Some people have been there before. Okay, so that was my code stuff that I wanted to show you. Snapshot facts. In multi-dimensional world, we always used to have to go and create additional facts to store point-in-time views of data. Okay. That, if you think the month end, we load every transaction, but at month end I must see what it looked like at that time. So you can do it, but it takes a whole lot more coding. In tabular, it's just not necessary. Yeah. Okay? So it saves effort. I'm coming here now to the things that I don't think people really care about in New Zealand. So please put your hand up if you want to ask any more. Otherwise, I'm going to go, this doesn't matter that much. Many-to-many relationships in the multi-dimensional model. So they work really well in that they're easy to design. They do create bridge tables. So if I'm a many-to-many table, relationship says I'm linking, the classic one I guess is sales, orders, many customers, right? So I have a bridge table which handles the relationship where I have that. And if you have a lot of rows in the bridge table, it can be slow to resolve. It's hard to work out the right way to make that process, and aggregations just are difficult. In tabular, you can't do many-to-many relationships with this version. You can only do one-to-many. But you can build them in DAX. Okay? So you can design those relationships using queries in DAX. It's fast, but it can be verbose. I haven't done it very often. It works, it's fast, it's good, but it's painfully difficult to read because it's quite a language with a lot of brackets. It's like being an accountant again. So many-to-many relationships, not a strength of tabular. Parent-child hierarchies. So they're supported better in multi-dimensional, right? And the reason I've got two boxes here is because in multi-dimensional, you can have these non-natural ones like the semester. So, and that's where you get these, when you're building them, you always get little red lines because I haven't worked out that the year must go down to the month, must go down to the day, okay? In multi-dimensional modeling, you can adjust the order of the hierarchy so you can make it do what you want. You can't do that in tabular. It only supports year, month, day. It won't allow you to put a semester in the middle or on top. Okay? Unary operators. Has anyone ever used these? I'm curious. I'm really curious. Whew. I know what they are. They are the idea is that you can change the way that the aggregation for a member property goes. So instead of just adding them, you can minus them. So it's used for financial calculations. The only time I've ever used it was many years ago in a different product. So we were trying to calculate things that differently, like plus, minus. So you can't do it in the tabular model. Apparently you can write it in DAX, and I've seen some code somewhere that I couldn't read because it was too long and I fell asleep. But no one's using them, so who cares? Custom rollups. So this is even worse, right? Has anyone used custom rollups in analysis services? Yeah. Yeah. Sure. So you can't do them in the tabular model yet. Financial cubes, currency conversions. MDX script. Okay. This is sometimes used, and you cannot do it in the tabular model, but in reality, the reason you would be doing it in analysis services is because it's easier to do it there than to put it back in the ETL where it really kind of belongs. So move it to the ETL. Hierarchies. Hierarchies in multidimensional are really rich and really important. They drive a lot. In tabular, they're not quite the same. They're not as simple, and they're just not there, which is why this stuff is at the back, because, yep. Okay, so should I migrate my solutions? We've kind of looked at what this does well and what it doesn't do. I wouldn't move anything if they're already working. It's a total redesign to some extent. What I would be doing is I'd be saying, okay, now I've got new use cases. Should I be using tabular model for this? Does this fit? Okay, and the key things to understand about that are the compression. Do I need to access every key? Can I just work with data that is not storing all of the IDs? Client access tools. I mean, I'm sure you can only use Power View with the tabular stuff at the moment. Okay, they're talking about that changing reasonably soon, but right now, if you want to use Power View, you need to use a tabular model. Okay, so that might be a good use case where you're going, I'm going to look at my data warehouse, I'm going to build a tabular model for Power View reporting. Okay. Key decision points. So, in my view, this is how you decide whether you should use one or the other. And a lot of it, I think, comes down to your background. If you're a MDX Superman, I would stick with it for now. If you've only got SQL 2008 R2 standard, you're not getting tabular models in SQL Server. Okay? So there's licensing concerns about going to the tabular world. But you could still start using it in Excel and maybe putting it into your huge SharePoint environment. It doesn't scale forever. If you've got a cube that is so big it's never going to fit on a server, then you're going to have to remain with multi-dimensional cubes. Chances are that cube's quite complex. It's got hundreds of hierarchies and many, many, many dimensions, and that probably should stay where it is for now. And translations of it, I don't know that that's a huge deal. I don't know anyone using translations. That's another question. Is anyone using translations? And look at that, there's one. Guys in the back. Can I give you one of these as well? Sweet. Okay, so tabular. I think if you're new and you haven't learned MDX yet, I would look at this because it's easier. It's way easier, to be honest. You can do it from Excel too, although I'm not going to recommend that. Lots of distinct counts. It's a no-brainer. It does distinct counts so well. That's the place where I would be saying, if I've got a lot of distinct counts, I want to use a tabular model for it. Okay? Or if you want to use this Power View toy, that's what it's for. But saying that, this is version 1, right? If you go back and look at the picture, what's happened, and you look at the release of 2012, very little has changed in the multi-dimensional environment. There's this whole new world that's coming, and it's probably, like they say, first cut, although I'd say it's almost second cut. It's probably only 80% there. And I would be surprised if they don't build those functionalities, all of the stuff there should come. It might just take a little while. Takeaways? So, to me, this opens it up. For me, the biggest thing here is that the fact that you can allow users that would have never gone near multi-dimensional MDX expressions and analysis services, you can allow them to learn how to do BI stuff with Excel, and they know the data, right? They work with it all day, every day. They're good at prototyping things. You can give those guys the tools and say, you go and mock it up, give it to me, and I'll give it to my IT guys who will fix it. They'll make sure the joins are right. They'll check the logic on the measures. That's a great thing. I think that's the biggest deal that's coming out of this, to be honest. The fact that we can create things here with a different set of people with different skills, but we can bring it into the managed IT environment. I think, tabular is awesome, but it's not great for everything. So if there's any sales guys, watch out for the sales guys because they'll sell it to you. That's what they do. It really does not replace multidimensional. They work together. And there's another piece which is tomorrow morning's lecture about the column store indexes. That's a third flavour, and all three of these things have good uses, and they all work well together. So I'd really encourage you to go and listen to that talk tomorrow. The technology's the same-ish. So if you understand how this works, you understand how it works there. You can use pass-through, right? And the column store indexes will give you great performance. The other thing is this hardware, right? It's not, don't throw it on the same box and think it'll work. You need to have really different hardware, and so there's going to be cost around putting that in place. But yeah, and design. If you don't think about what you're building, you really need to have an understanding of what you're trying to do. It comes back, BI is all about the data. You know, you have to know the data, and once you know it, then you can understand the right way to build a solution that meets your client's needs. Which is why I've kind of gone the architecture route on this. And that is, to be honest, all I needed to say, really. I have some things you should go and see today. Everything's in this room, so you don't have to get up. I'm really curious about the extraordinary things with SSIS. And tomorrow morning, the turbocharge your data warehouse queries with column store indexes. I'll be sitting here, but don't talk to me too loudly. It might hurt. Okay, if you want to contact me, I'll be downstairs on the race cars later, playing. Sure.
How fast is it load a billion rows that you've got? Like,
Oh, yep.
and in columns of that, you read that data multiple times for each property?
Yeah, so what I didn't talk about is partitioning. So let me show you my table. So you can only load things at a partition level, right? So you can either load a whole table of 1 billion rows, which will take a long time, or you can load partitions. So to build my 1 billion rows, I've hit my other table and I've created separate partitions. Okay, each one's, I started small and then I got brave and went to 100 million. And they were taking like an hour or so to load 1 billion rows. Oh, sorry, 100 million rows. But it's just the fact internet sales thing minus some of the expensive keys that I wasn't using. Sorry? I was really impressed with the speed. So it's fast, but I mean, I've got a laptop, right? It's difficult to compare speed when it depends on the hardware you're playing with. Okay? But the other thing you can do, which is really worth doing, is if you go and look at the tables, it is all just sitting under SQL Server.
But it's surely a multi-dimensional one. You actually read one row once and calculate giving all the data for that one row. Now you're going to be reading 50 billion rows.
What it,
How many columns you've got in it, or not?
it processes it. How does it process it? Processes it column by column, right? It picks an 8 million. Sorry, rephrase that. It pulls in 200,000 rows, and it works out roughly what they are, and that allows it to work out the algorithms and make some ideas about what it's going to put in its dictionaries, and then it starts processing the data based on that. So what it needs to determine at the beginning is, am I going to use which one of these compression ones is going to be most effective for this kind of data? Okay, and it can guess based on the first 200,000 rows. And it might be wrong because you might have a different type of data in the first 200,000 rows and then it might change. It does it in sets of, I think, 200,000, and then it stores 8 million in SQL Server in a time. Okay, if you're doing it in SQL, it does 1 million at a time. But what I wanted to show you is if you look under here, and this is really useful to know, is you can go and just have a look at the tables and you can see the size of them. So what I was doing when I was building this, I was going, well, how much can I fit on here? Because if you put too much, it'll process for 2 days and then it'll just stop because it runs out of memory. But you can come in and you can look at the size of the the tables, there'll be a folder. Here's my folder for the internet sales one. And you can see, which of the columns is big, right? So I can come in here and I can go, oh, do I really need that sales order ID? Because it's taking, 4 gig of the 9 gig of my database. Now, am I really going to analyze that, or can I just not bring that in? Does that make sense? So, and that will speed things up massively, because what it's saying is it's a sales order ID, and I can't really summarize that. So I just need to store 5 gig for those, because you reckon it's really important. So that 4 gigabyte there is the data set for the sales order ID. Okay? So if I took the sales order ID out of my tabular database, it'd be down to 5. Okay? Does that answer your question? Any more questions? Oh, I'm not doing very well at giving things away. I've got a bunch of these. If someone wants one, come up afterwards. I've got one really good thing. So the next good question can have it. It's a Arc Touch mouse. Sure. If I can answer it. Yeah. Yeah. It would be hard. Well, no, so, yeah. Yeah, it would be hard. But chances, so my sales order ID doesn't link to anything, right? What I'm saying is I want to store the sales order ID in the model. And the reason for that is because you have actions in the tabular model, but the only action you can have will be a default action to return the rows. Okay? So if I've got the sales order ID and I allow an action to return the rows, I can get all the sales order IDs that I want. Yeah? Whew. Okay, you can have that. Is there any more questions? Cool. I think we're done then. Oh, please be very gentle.